good enough, Joey.
Alright, good. Alright, so what you should have gotten out of yesterday was a geometric series usually looks like this, a times r to the n. And when you write it out, you're going to have like, well, let's see, if n goes from 0 to infinity, you're going to have like the first term, and then the second term, and then the third term, and whoops, the fourth term, blah, 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 blah. Right? So you'll have like, a is called the first term, r is the multiplier. And to find out what that series adds up to, we have a formula for it. And the formula was, is it a or 1 minus r? Yeah. So, basically, you can take a geometric series, and I know it's geometric because I have a multiplier from one term to the next. And I can find out what the sum is by using this formula. So I didn't really get to any major examples. We looked at the one that added up to like 111.1 repeating, and then we looked at the other one that diverged, that added up to something cubed that we couldn't like quantify. Well, to know if it's going to converge or diverge, all we have to know is what's r. And if r is between 1 and -1, then the series will converge. And if it's outside of that, if it's bigger than 1 or less than -1, or it equals those things, then the series is going to diverge. So remember yesterday, I think I had like, it was like 5 to the n, or whatever the heck it was, I don't remember. And it just got so big, and we could clearly see that the thing was getting huge. And then when we used 0.1 as r, we could see that the limit was going to 0, because we could see that it was getting smaller and smaller. It was going to be converging to 0, or the limit was going to be 0. So if r is between -1 and 1, the series is going to converge. The way we often write this, instead of writing it like this, people will write the absolute value of r is less than 1.
Sorry.
Does it make sense that equals the same thing?
And can it be 1 or?
It can. So sometimes instead of seeing r has to be between -1 and 1, you'll see the absolute value of r is less than 1. And that's what that means. If the absolute value of r is less than 1, it means the distance away from 0 that r is less than 1. So it's got to be between -1 and 1. And then if you write it the other way, the absolute value of r, if it's greater than or equal to 1, then the series is going to diverge. So right away, when you're doing a geometric series, you can just look at what r is and decide whether it converges or diverges. If r is between -1 and 1, the series converges, and I can use this formula to find out what the sum is. So it would look like this. If I have the series 3 times 1/2 to the n minus 1 n equals 1 to infinity. I just use this example just so that you see that it doesn't always have to look exactly the same. It doesn't always have to look exactly like that to be geometric. Because I have experience, I now know what's geometric and what's not, kind of by looking at this. But I never knew that when I first started. So what I would do when I had a series is, I would write out the first few terms. And if I had a first term and then this constant multiplier, term by term, I would know it was geometric. So like if I plug in 1, what do I get? What number? 3, right? Because 1 minus 1 is 0, so that's going to be 1, so it's just 3. Plus my second term, so when n equals 2, 3 over 2, right? The next term, if n is 3, 3 over 4, plus blah, 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 or 3 over 8, blah, blah, blah. What I want to be able to know is what's a and what's r. A is the first term, so what's a? 3. And r is the multiplier. What's the constant multiplier from one term to the next? 1/2. Okay, I knew that because look up here. The basic geometric series is a times r to the n. So here's a, here's r. It was n minus 1, it didn't matter. It could be n minus 1. It doesn't really matter what that looks like, but that's why I usually get the first few terms to make sure I have it all like worked out. Does this series converge based on what R is?
Yes.
Yes. Okay, because R is between -1 and 1, the series is going to converge. So what does it converge to? A over 1 minus R. So 3 over 1 minus a half. 6?
Oh,
Did you say 7?
yeah.
I get 6. So this series, if I were to add up every number from 3, or from n equals 1 to infinity, I would get 6, which is just nuts to me. So this is like 3 plus 1 1/2 plus 3/4 plus 3/8. Like I'm adding on less and less, but what I'm adding up is eventually getting me to a sum of 6. Isn't that crazy? It's kind of nuts. I wouldn't think it was that high, but I guess 3, this is 4 1/2, and then you're at like 5 1/4, and then you're at like 5 and... Yeah, 5 5/8, so, okay, we're getting closer to 6. You guys don't seem as blown away as I am.
It kind of just happens.
Okay. I'm not going to erase
The
this.
math gods declare.
I just believe in magic.
Right? If you believe in magic, then you believe in math.
You know?
Okay, let's say I'm given a series like this.
1.38. I don't know why.
Sometimes it won't be written in this like series notation for me. Sometimes I'm just going to be given a series of numbers, and they're all added up or whatever, and I'm supposed to figure out what the deal is. Well,
What's my x equal?
there is an alternator, but it's okay, because as long as, so what's A? A, my first term is 1. My R is just what do I multiply each one by to get to the next one? -1/2. So yes, there is an alternator. If I were to write this as a series, I'd have 1 times 1/2 to the n, and then maybe I'd also have a -1 to the n. Now I can also, we're not at this point yet to write these, but we will get there. If I wanted to try to combine these two things, I could. God bless you. This could just be -1/2 to the n, which is the same thing as having an alternator. It's just not explicitly there, but it actually is considered an alternator because it's a negative number to the n. You don't need to worry about this yet. You just need to know that I got my first term, I've got a multiplier. The multiplier is in the range that they tell me it needs to be in for it to converge. So the series converges to A over 1 minus R. So 1 over 1 plus a half. So what does it converge to?
2/3.
Is it? Oh yeah, sorry. I didn't mean to doubt you. 2/3.
No, it's okay. I'm just doing it.
Doubt him.
2/3.
I like to yell things too.
Alright, and then you might see another one. Just wanted to put this up there. Again, I'm not erasing this because I'm going to go back to it in a second. Pi over 2 plus pi squared over 4 plus pi to the 3rd over 8 plus blah, 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 blah. This is another series. The first term is pi over 2. The multiplier is what?
Pi over 2.
Also pi over 2.
What a trick.
Is R between -1 and 1?
Nope.
Nope. So it diverges. So once R is too big, it's bigger than 1 or less than -1, then the series diverges.
And that's it. And that's all you gotta do.
Yep, so this is bigger than 1, so series diverges. Done. So take a look at R and make sure that you do
So it
that
does
before
not
you go
exist.
plugging it into the formula. Okay, so what the heck? Like, I think this is confusing. What is this whole R and Y? Here's where we're going to use a calculator.
Joel thought.
Okay.
I'm on it, dude.
Okay. So, geometric series take on this form, A over 1 minus R, right? I know this is so exciting. I'm sorry. I wish it was more fun. But it's just not. We're going to look at with the most basic geometric series. Tell them to stop having fun. It's annoying. Okay, so a geometric series takes on this form, but A can be anything and R can be anything as long as R is between 1 and -1. The most basic geometric series actually looks like this, 1 over 1 minus x. When I do that, it's of this same form. What is my A going to be?
1.
1. If I look at the way this geometric series works out, and this is like a model for it, if I'm using a specific one, like I'm not using an A anymore, and I'm not using R, I'm going to specifically use x and then a number for A. A is 1 and R is x. So if I were to write this out, the first term would be a 1. What would the second term be?
1x.
1x, yep. X is my multiplier, so 1 times x is x. What would my next term be?
X squared.
Awesome. 1x squared, x to the third, x to the fourth, and so on. Okay, so here's the weird connection. This function can be modeled by this polynomial, and they are exactly the same thing. If I were to graph this function, and I were to graph this polynomial to infinity, they would be exactly the same thing. But they would only be the same thing when x is between 1 and -1. And outside of that, it wouldn't be the same anymore. And we're going to take it and graph it and take a look at it. So, take your calculator. So to answer the question, like, why does the series converge only when x is between -1 and 1? This isn't going to exactly tell us why, but it's going to kind of show us. So take a second, and in your y1, put in the function 1 over 1 minus x. Oh, shut up, you stupid.
What?
Not that I'm talking to Jared. Just kidding.
Talking to Jared.
Gotta cheer him on, not put him down.
Just kidding. I don't even know how to use this calculator. Okay, so in your y1, graph 1 divided by 1 minus x. For you calculator troublemakers, make sure you put the denominator in parentheses.
I did.
I didn't want to just say
For Alexis.
but
But Jim did it for you.
okay, just graph that for a second.
I thought about it.
Whoa.
Well, we should know what that looks like, right? Don't fall.
I can't do it.
Okay, 1 over 1 minus x should have an asymptote at 1. And what was it? This one was down? Yeah, because it's negative. And this one's up here. Let's make our window smaller. So we're just, well, no, you don't have to. If you're -10 to 10, that's fine. If you're like something other than that, I would change your window to standard, just go like zoom standard or whatever. And now go back to your y equals and go to the y2. How do I graph something else on this stupid Inspire?
You don't.
None of you guys have an Inspire, do you?
You're on.
I uses. Well, I have
She has to
the
use.
other faceplate.
Yeah,
They're
not
not-
stupid.
She's a lying Inspire. Or Inspire.
A lie spy. Okay, whatever.
So I spy.
How do I graph something?
It's like a little computer. It's not necessarily. It takes
Oh, got it. Okay. All right, in the y2, we're going to graph part of this series. Now, let's like be crafty, and let's just graph like the first 3 terms. Because am I ever going to be able to graph the entire series?
Yes.
How long would it take me? Infinitely long, okay? So the series is infinitely long. So let's just graph 1 plus x
Oh my god, it's the same.
plus x squared.
It's the same
Alright,
thing.
spoiler alert, Colin. Jeez.
Oh,
It's not even the
a little bit of anger going on over there.
Now, it's like so not the same. It's a it's a parabola, right? 1 plus x squared. We know that that's a parabola. So it's this funky parabola, and it's, oh, I don't use green again. That would be crazy.
What?
Mix up my
It's exactly.
Well, let's give our series some more terms. So go back to your Y2, and let's put in the first 5 terms. Go all the way to x to the 4th.
I went to X.
What are we doing now? Let's go to x to the. They do
Oh my god.
put on x to the 3rd and x to the 4th.
In the same Y2.
Yeah, like go redo it.
I'm scared.
One up to 7.
I'm pretty scared.
That's not what it sounds like. So I go read this. No.
Yeah, run after me right now.
Right now.
Right now, do it. Yeah, 7 makes it the same thing.
Okay, so that's not the
See, I
one.
got it. Like, I don't want to think it's to the.
Okay, still not quite there.
We don't
We
think
need
it's
a jar open
X
here.
to the 4th.
Oh,
Not as far as
you alright?
What did you just do, dude?
I just see it like.
Okay, is it any better? Is it any more of a match? It should have matched up even better, but what are you noticing? It only matches from what to what?
What? Negative
0 to 7.
It only matches from -1 to 1. Other than that, it stops matching. It goes off totally on the left and on the right. It doesn't match at all. Well, the more terms I give the series, the more exact they're going to be, but they're only going to be exact on that interval. Holy monkeys, isn't that amazing?
I love monkeys. Why are they holy?
I don't know.
Someone shoot at
The Pope.
The Pope.
the new.
So, here's
The
the
Pope is
thing
from
about
Ohio.
series. And here's the only cool thing,
Is he?
because this is kind of cool. Series allow us to take a function
That was a quote from Eurotrip.
and rewrite them as a polynomial. And they're equal. Only from -1 to 1. But, woo!
You probably should.
Wow, he's
Should I
out.
write this as a if you want. So,
So,
if I take a series and I know that this series, that this function equals this series, that's like a big deal. I don't know why, but it is kind of a big deal. And the more terms of this I include, the more they're going to match. And if I include an infinitely large amount of terms, they'll match exactly.
My brain.
Okay. Oh, so one thing I want to tell you is that this has a fancy name. This is called the interval of convergence.
Is that for every single one?
This is going to be for every geometric thing.
Dude, my Falcon team looks like chickens.
You're starting to draw one. Look at that, it's a chicken. It's like a baby chicken.
doesn't that sound amazing?
Getting good quality, getting real artsy.
The interval of
My
convergence.
Falcon yesterday was so much better.
Sounds like a.
But we can have other
The one
geometric.
yesterday.
Yeah.
It was still like a.
We can have, so that's our most basic and simple geometric series. It's just that. It doesn't have to look like that. It could look like something else. Like, for example, 3
Oh,
over
that
1
looking
minus
better.
x to the 3rd. That's a geometric series. You're going to start pulling out the idea that if it looks kind of like this, it's geometric. If it looks like something over something minus something, it's a geometric series. And I want to say, all right, well then A was 3, and R is x to the 3rd.
Birds.
So this series looks like 3 plus, this is my multiplier, 3x to the 3rd plus 3x to the 6th plus 3x to the 9th plus blah, 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 blah. And I just took a function and rewrote it as a series. And this function and this series are the exact same thing graphically, but only when the r is between 1 and -1. So my interval of convergence, because you're going to be asked for that.
Is it always just?
For now, it's always just the r has to be between 1 and -1. So my r might be different. Right now my r is x to the 3rd. So my interval of convergence is x to the 3rd has to be between 1 and -1. So I go solve for that x. In this case, it's not going to change anything. When I cube root these, I'm still going to have my interval of convergence is between -1 and 1. Nothing changed. See if I can find another one for you. Okay, yeah, let's do this one. Okay. I know. Do you know there's like 64 days of school left?
Thank
graduated and out of high school, except for Dan.
Yeah.
And totally on your
Sucks.
own.
There's 60
Hallelujah.
days till spring break, 30 days till Disney, and 66 days till prom.
You mean like including weekends and all that?
Yeah.
Yeah.
When is prom?
I was gonna say 66 days.
Makes sense.
Yeah.
17.
66 days from now.
Almost there, man.
66 days.
Final stretch.
Thanksgiving.
Nope.
No one did even.
Jared, yeah, Jared.
Electric air conditioning is extremely necessary.
I see the Falcons.
You need fireworks too.
Okay, your questions would be, number one, write a series for this function. Number two, find the interval of
Dude,
convergence.
stop
No.
shaking the
Look how fancy
table.
that sounds, and you guys can do it.
Yeah.
Nah.
A equals
equals
1.
one.
R equals 2x.
A equals
So
1,
the first one is
R
R.
equals 2x.
Then 2x.
I don't,
No, that's if that's
That is the
plus
series.
whatever.
We're going to do that one next.
It'd be
Negative.
R equals negative.
Exactly.
It'd be 2x.
Good thinking, dude.
It'd be 4x squared. Thanks, endpoint.
No, it is 4x squared.
So thanks, endpoint.
You multiply. R is your multiplier.
Oh.
Okay.
So you see that, like, when I have this in a function notation, I'm not saying it diverges ever, because there's an x there. So, like, I'm forcing the interval of convergence on it, instead of being told, oh, well, my r is bigger than 1, so it doesn't converge. Do you know what I mean? Like, the first couple we looked at, r was a number. So I was able to know exactly what it added up to, or else r was too big, and I'd say it diverges. But now that r is a variable, I'm going to write the series, and I'm going to say, okay, well, 2x, though, has to be between 1 and negative 1 for this to converge.
That's what I got.
So x itself has to be between 1/2 and negative 1/2. This is your interval of convergence.
Oh my goodness, I'm confused now.
Yes.
You need to.
So, if I graphed the function and the series, where would they be the same?
It'd be negative 1/2 on it.
Only from here to here. So this interval of convergence is smaller because of the nature of r.
So if you had x squared, it like wouldn't work. Or
If I-
whatever. 'Cause,
If
like,
I had x squared, it wouldn't work. It'd be different. Yeah. And not even necessarily wouldn't work. We'd have to be creative. So we'll look at
Just
that
take
later.
the square root.
But you couldn't take a square root of negative 1.
Yeah,
so like,
because you
square-
get I.
but
everything
but
like
I
this
just
Just
below.
don't make the mistake.
oh, you do have a
Okay, so the interval of convergence does, I guess, matter. That function matches that series only on this interval. So if we
Okay.
graphed it, they'd be the same only on that smaller interval. All right, and like Nate was saying, what if it's a plus instead? Everything we've had has been minus.
I'm smart with
Just don't make the mistake.
okay.
You know, like spot ketchup.
So if it
Little
was 1 over 1
sponge.
plus x,
It'd be A is 1 and R is negative x.
yep, a is 1, r is negative x.
No, because I understand.
Wait,
Why did I write negative 1? So 1 minus x plus x squared minus x. And then this interval of convergence, negative x would be between 1 and negative 1.
Just take the negative out.
Yeah, if I multiply everything through by a negative, what happens when I do that? The signs do change.
Yeah.
What's the same thing?
What is the same thing? In this case, when the signs all flip, it's the same thing. I know, one thing we didn't talk about
the weirdest video ever.
is how can I write this then as a series? So we're also going to take these things and try to write them in series notation so they don't always have to have this like string of terms all expanded. And this gets a little bit hard.
Could you just do negative x to the end?
Nope, you're wrong. Damn.
Mm.
I think this
Now, two things. One thing is it has an alternator. If you want to just always have like a systematic way of doing it, you could be like, okay, this is negative 1 to the n, and then this is x to the n. You could put it together. It doesn't matter. Sometimes it's easier to have the alternator separate. You might also need to juggle what n is equal to. So let's think, if n is equal to 1, does this work on the first term? Yeah.
Just kidding, it doesn't.
No.
It
No,
has to be
it gives
0.
me an x, so that doesn't work. If n
Has to
equals
be.
0,
Yeah.
does that work?
Heck yeah.
Because that makes this 1 1 also makes this a positive 1, so I'm good. The second term when n is 1, it's going to be x out of the negative 1, so you'll be good. So that's writing the series. What are you guys looking at?